So what are you thinking about for that one there? Yeah, so the whole denominator, right? This whole denominator has to be greater than 0. Strictly greater. It cannot be equal to 0. Why can't it be equal to 0? Hold on. Are you saying the denominator, or are you saying just this radicand like that? Yeah. Yeah, the thing underneath. Now let's discuss this. 4x minus x squared can't be 0, right? Because then you would have division by 0. But 4x minus x squared can't be negative either. Because if this is negative, you're trying to take the root of a negative number, and you can't do that. So 4x minus x squared must be strictly greater than 0. We all follow? How do you solve that? This one's tricky. Not tricky, but I see this done incorrectly. So this is called a quadratic inequality. And the way you do this is not the same way that you would do it if this was an equal sign. If that was an equal sign, then you would just like factor and you'd be in business. But because it's an inequality, you have to do something else. So there's some steps to do it. Subtract or add what?
Subtract or add one of those to the other side, but when you do that, you would have to change the greater than.
When do we flip the inequality symbol on an inequality? If you do what? Multiply or divide by a negative. So adding and subtracting wouldn't affect the inequality. It's the multiplying or dividing. But even then, if you move that thing over, like let's say you added x squared to both sides. I think you'd still be in, like what do you do with that then? Right, what do you do? So the proper way to go about this is to first make it in equals, okay? First make it in equals, and you solve it, okay? Just like you normally would. So how would you solve that? Factor out a common factor of x. Be left with 4 minus x equals 0. So I just pulled the GCF out there, and now you can set each of those factors equal to 0. So what happens when I set this to 0? I get x must be 0, and then set that to 0, and you get x must be 4. Okay? So I'm trusting that you could get those from here. All right? Side note, there may have been somebody in here that wanted to do this. Would that have been okay? Could I mean, algebraically, can I move that to this side? It's not a trick question. I mean, does that seem okay? All right. Not with the inequality. With the equals, though, that's okay, right? And then how about this? How about this? Student does that next. What did they do?
Couldn't do that because you got a square.
What did they do? What did I do from here to here? I divided by x. Is that okay? I divided both sides by x. So what is this final line saying here? My answer is what? 4, right? Was 4 one of my answers? Yes. But what's wrong with this? I'm missing an answer, right? How did I miss an answer? Well, when I divided by x right here, there's a little asterisk when I do that. When you divide by something, you better promise me it's not 0. Do you see that? What I'm trying to get you to see is that solving this equation this way and dividing both sides by x, you miss a solution this way. You don't ever want to divide an equation by a variable expression, because then that variable expression, you have to promise me it can't ever be 0. And so you lose a solution. This is the proper way to solve. You factor and then set each factor to 0. Then you won't lose any of your solutions. That's just a little side note. Okay, so back to this. We were saying this had to be greater than 0. So then we said, all right, well, let's first see where it is 0, right? So this is where that expression is 0. So now I draw a number line. And on this number line, it breaks my number line into 3 separate regions. And then all I'm going to do is test numbers within each region. And when I say test, I mean I'm going to pick a point over here, any number I want, -2. Pick some number here, how about 2? Pick some number here, how about 6? And I'm going to check these where? Where am I going to test these 3 points? Into this thing right here. And see if it's true or false. So let's try it. Let's plug in -2. What would you get if you plug -2 into this? You get that, right? Replacing -2 into this expression. Is that true? Is it? This is -8. What's this? That's 4, and then so -4. Is that bigger than 0? No. So that's no good. This does not work. Nothing over there will work. Then you plug 2 in and you check it. And will that work? 2 into there? Yes. 2 here? 8. 2 here? 4. 8 minus 4? 4 is bigger than 0. Works. And then here, if you plug in 6, you check it yourself, it won't work. And that means that anything between 0 and 4 will work. Anything between. Now, do we want to include 0 and 4? No, because remember, if we get 0 or 4, that makes it 0, and we said we didn't want it to be 0. So the end of this, the domain is x must be an element of the interval 0 to 4. I'd say the main idea behind this problem was to make sure that you remember how to solve a quadratic inequality. Because this technique you're going to need as we progress. There's an easier way to do this, I think. Look at this real quick. You still have to do this step, and this step. And you draw your number line. Okay, you still draw your number line. But then, just tell me about that I boxed in red there. What does that look like if I asked you to graph it? What is this as a graph? Quadratic, right? Which way does it open? Down, because you have a negative in front of x squared, right? So that should look like this. And I know that this and this are where that graph would hit the x-axis. So these are the x-intercepts of that graph, aren't they? And if it opens down, then it has to look like that, doesn't it? And what we're asking ourselves is, when is that parabola greater than 0, right? So when is it above the x-axis? Well, right there, right? Between 0 and 4. So once you get these, if you know what that looks like, you don't have to do any test points. You can just draw a quick little parabola and be like, oh yeah, here. Make sense? All right, last one, h of x. What time do we go to 240, right? H of x. What's the domain of that? Secant, by definition, secant is the reciprocal function of cosine, isn't it? This is 1 over cosine x. That's the definition of secant. So if you look at that now as a ratio, we know that that would only run into a problem if we had cosine of x being 0. Do you agree? So that's what we have to ask ourselves. Where is cosine 0? When is cosine 0? So this is all going to depend on your pre-cal, all right? And everyone's learned pre-cal a different way, I'm pretty sure. So let me ask you that question. When is cosine of x 0? And let's see what kind of responses we get here, like how they're doing it. Pi over 2? So where are you getting that information? Like what are you thinking when you answered that question?
Cosine is equivalent to x, sine is equivalent to y, and I just have the pi, the circle.
Circle. So you're visualizing the unit circle.
Yes.
Okay. Who else visualizes the unit circle here to answer that question? Okay. Does someone do something different? No? Okay. The unit circle is the way to go. All right? So I want to make sure everybody understands this. We have the idea of the unit circle. There are very important points along this circle that you should have pretty much memorized at this point. You know, like this point right here is the point 1, 0, right? And then there's one that's like exactly halfway at 45 degrees or pi over 4, and that's, you know, root 2 over 2, root 2 over 2, right? And then there's all these other important ones around here, yes? So when you're saying cosine of some angle, and let's change x to theta. When you say cosine of theta is 0, you're saying at what angle is what 0? At what angle is what 0 here on this circle? You said it. It was x is the cosine. The x coordinate is always cosine of the angle, and the y coordinate is always sine of the angle. So when someone asks, you know, cosine of what angle is 0, you're saying to yourself, okay, where on the unit circle is my x coordinate 0? And that happens here and here, right? At two places, I have an x coordinate of 0. So my answers are what? You said, I'm going to stick with theta. Theta is pi over 2, but that wouldn't be the only answer. 3 pi over 2, right? Those would be correct answers. Do we all agree? But this is not the correct answer to this problem because that's only 2 answers. How many answers are there? Infinitely many. Because there's no restriction here on the domain of that function. We're saying where, you know, when is it? When is it 0? When is cosine x 0? Happens here, here, come back, come back, come back, come back. Or you could have started here and gone negative pi over 2, negative 3 pi over 2, right? So as long as you land on that spot or that spot with some angle, that's a solution to this, right? So how do we do that? How do we represent all infinitely many answers? Well, again, this depends on how you were taught. Okay, I'm going to show you how I teach my students. First thing I do is I say, all right, I notice that these angles are completely, like directly across from one another, right? So if I started at this point and I wanted to get here, all I'd have to jump by is how much? How much would it take for me to jump around to that? 180 degrees, right? Pi is 180 degrees. Pi radians would jump me here. And if I did pi again, I would jump back, right? So by just jumping by pi, I'm going to go back and forth between these two. Now, if these two were not directly across from one another, I wouldn't be doing this, all right? But because they are, I know that if I start here, add another pi, I'll be here. Add 2 pi's, I'll be here. 3 pi's, I'll be here. 4 pi's, I'll be here. 5 pi's, 6 pi's, 7 pi's, right? So the way I could answer this to give you the general solution would be that theta must be, well, we start at pi over 2. That would start us here. And then add to that angle any multiple of pi.
So pi k?
Pi k, or k pi. Some books use n pi, or pi times n. It depends. How many of y'all used k? K? Anyone use n? Does it matter to you? Okay, so I'll put k here. K pi. Here is understood that k is an integer. What are the integers? 0, 1, 2, 3, forever, right? But both the positive and negatives. So it's like if you put 0 in front of this, you get pi over 2, right? Which is one of your answers. If you put 1 in front of this, you get 3 pi over 2, which is another answer. And that means you're like jumping. Then 2 pi's would jump you to here, 3 pi's, 4 pi's. So this is the answer. Now, that's not the answer to that, but that we were asking ourselves, when is cosine, at what angles is cosine 0? We said this is it. So how do we represent our domain? Because we don't want those, right? These are the things we don't want, because this would make it 0, wouldn't it? And that would give us division by 0. So the way I'm going to write this is I'm going to say x is not an element of. Okay? Instead of telling you what x needs to be in the domain, I'm going to tell you what x can't be. Because it's easier for me to tell you what this is rather than to try and represent all infinitely many intervals for you. So x cannot be one of these, right? So it cannot be pi over 2 plus k pi. Any other value of x is valid, would be in the domain. All right, I hope that makes sense. If this whole thing that I did here with all this unit circle is troubling you and getting these general solutions, again, please come by. We'll sit down. We'll talk about it. Let's not wait till it's too late. All right. Okay, these problems are a little different. So again, shifting gears into something different. Can we express the area of a circle as a function of its diameter? And the area of a circle as a function of its diameter. So here's what we said earlier when we were talking about areas of circles. We said the area of a circle is pi r squared, right? Written like this, the area depends on r, doesn't it? You give me r, I give you area. So area depends on r. But I want us to express the area of a unit circle, or of a circle, as a function of its diameter. So I don't want r in there, I want d in there instead. So what can you do to make that area equation be a function of d instead of, or diameter instead of radius? What do you have to do? Pardon? Yeah, I mean, what's the relationship between radius and diameter? So we know that the diameter is twice the radius, yes? And what I want to do is replace this r with something that has d in it. So if I take this and divide both sides by 2, and this is where you could have said the radius is half the diameter, it's the same thing, right? Then I can rewrite that formula, pi, and then d over 2 squared. So all I've done is I've replaced r with something with d in it, right? And now let me do this. So what did I do there? Squared a fraction, so you square the top and bottom separately. Square the d, you got d squared, square the 2, I get 4. So then I pulled the 4 out front as a 1/4. So I got 1/4 pi d squared. That is a new formula for the area of a circle. Now that's not the one that's sitting in textbook. This is the one in the textbook, right? But this one could have very well have been in textbook also. It's the same thing, all right? This one's better if we know the diameter, right? That one's better if we know the radius. Does that make sense how we did that? Okay, now let's look at the next one. That first one was kind of a warm-up one. Let's see what this next one is. Express the volume of a cube as a function of its surface area. The volume of a cube as a function of its surface area. Okay, let's draw a cube first. That's cube. Now cube, we all agree, means all sides are the same length. Length of all sides are the same. It's not like a shoebox, right? Like a shoebox, you could have, this side longer, but a cube, all the sides have the same length. Okay, so let's call the length of these sides, how about x? X, that's x and that's x. What would the volume of this be? what would the volume of that be?
X times X.
X times X times X, right? So the volume of this is X cubed. Right now, the volume is a function of what? The volume is a function of what? What do you need in order to tell me volume? X. And X is a measurement of what on the cube? The length of the side, right? What we want is we want to express the volume of a cube not as a function of the length of the side, but as a function of its surface area. What? That means volume needs to be equal to something over here with surface area in it, not X. So we need to somehow connect X and its surface area together. You know how with the last one we connected R and D together? Help me connect X to surface area.
X squared times X.
So surface area would mean the area of the outside, right? So what would be the area of that right there? The area.
X squared.
X squared, right? This times this, right?
Yeah.
That flat surface would be X squared. That'd be the area of that. So the area of that is X squared. And so is this one, right? X squared.
Yeah.
And so is this one. And then there's backs under, right? How many of them total? 6 of them, right? Agreed? So I'm going to write this over here. Area. Now, do we understand? I mean surface area here, all right? Surface area of that cube is 6x squared. You with me? Sure? Now, I need to rewrite this formula. I need to replace x with something that has surface area in it. This is the relationship between x and surface area. So what do I do with this? I want to have x, right? So why don't I take that and solve for x? How could you solve this for x? First step would be what? Divide both sides by 6. I'm going to do that instead. It's the same thing, right? 1/6 of a is the same as a divided by 6. And then I'm going to take the square root, right? I'm going to take the square root. I'm pulling the square root out and I am applying it, which means I should be looking at what when I do this?
2 answers.
2 answers, right? So I'm going to do square root, I'm going to do plus or minus 1/6 a equals x. So I took the square root on both sides. But I'm actually going to throw away the negative 1 now. Why am I going to throw away the negative 1?
Because this size cannot be negative.
Yeah, because this is x, right? And we don't have a negative length. So algebraically, look, algebraically from here to here, algebraically you have to include plus or minus. But within the context of the problem, I can throw the negative out. So I'm chunking the negative, I just get 1/6 a equals x. Okay, so that's now a relationship that I have between x and a. And now what I'm going to do is I'm going to come back over here and replace that x with that expression. So my volume is now the square root of 1/6 a, but all of that, what? Cubed. Right?